All right, so we're going to continue looking at 5.4, and then we'll start to take a look at 5.5, and we'll see how far we get into 5.5. We might finish it. We'll see. All right, so first thing is just a reminder of what a unit vector is. It's a vector that has a length of 1. Okay? It's a vector with a length of 1. So what I want to do is figure out, if I give you some random vector, I want you to be able to turn it into something exactly 1 unit long. If I give you a vector that's too long, you're going to have to shorten it to make it 1 unit long. If I give you a vector that's too short, you're going to have to make it a little longer. Okay? It's still going to point the same way. It's just going to be exactly 1 unit long. So let's see if we can figure out kind of a formula to do that. Let's say I gave you a vector that had a length of 5 units. What would you have to scale it by to make it 1 unit? Okay, it's 5 times too big. Yeah?
1/5.
You would scale it by 1/5. Okay. What if I gave you a vector that was half a unit long?
2.
You would scale it by 2. Okay, let's do one more. What if I gave you a vector that was 3 units long?
1/3.
You'd scale it by 1/3. Does anybody see the connection between how long the vector is and what you need to scale it by?
You just divide it by the reciprocal.
It's scaled by the reciprocal of its length. Yep, exactly. You scale it by the reciprocal of its length. All right. So this is going to be to find a unit vector if I give you a random vector. We're finding a new vector. It's going to point the same way, but we're going to make it exactly 1 unit long. We might have to shorten it to 1 unit. We might have to lengthen it to 1 unit. But when we're done, it's going to be 1 unit. So the formula is how am I going to word it? So we said you have to scale it by the reciprocal of its length. What do we use for the symbol to show length for a vector? What is
The arrow? Or is that just the symbol for vector?
So there's a symbol that if you write this down, it means magnitude. We remember from yesterday?
Is it the double line?
The double bars. So to represent scaling a vector by the reciprocal of its length, here's your vector. You're going to scale it by 1 over its magnitude. Or if you simplify it, it's v divided by the magnitude of v. It's the same thing. And that will always give you a unit vector. If you take a vector and scale it by the reciprocal of its length. That's the key. It has to be the reciprocal. And I think most people notice that from the pattern up there. All right, any question on the formula? Okay, so step 1, you have to find the magnitude of the vector you're working with. Step 2, scale it by the reciprocal. All right, let's try an example. So let's find the unit vector for 3i minus 4j. First thing we have to do is find the length of the vector we're working with. If it's already 1, then we don't have to do anything. But chances are it's not going to be 1. Okay, so from yesterday, what theorem do we basically use when we're finding the magnitude? Yeah, it's really just the Pythagorean theorem, which starts out with what symbol?
3 square root.
Yeah, start with a big square root. And what's going to go under the square root?
3 squared.
3 squared
Plus 4.
plus 4 squared. This negative doesn't matter because when you square it, it's going to go away anyway. So you're basically finding the hypotenuse if you go right 3, down 4. I want to know what that is. Okay. All right, what's 3 squared? 4 squared? Okay, so that's the square root of 25, which is how much? 5. So 5 is the what?
Magnitude.
It's the magnitude. So do I have a unit vector right now?
No.
No. It's supposed to be 1 unit long. This is 5 units long. So what does this vector need to be scaled by?
1/5.
1/5. So what I want to know is this. What's 1/5 of v? And that's my answer.
So you plug 5 into V.
So you're going to take that 1/5 and you're going to distribute it to each component. Right? What's 3 times 1/5? As a, well, leave it as a fraction. What's 3 times 1/5? How much? 3/5. Yeah. So 3/5 pi minus what's 1/5 times 4? 4/5. Check. So that's a vector that points exactly in the same direction as the original. It's just 5 times shorter, which means it's a unit vector. Now, everyone understands you don't always make it 5 times shorter. It's just this one was 5, so we needed to make it 5 times shorter. If it was 8, we'd make it 1/8, 8 times shorter. All right. Any questions on finding a unit vector if I give you a vector? Okay, and if you're kind of wondering, you're going to see this in the next section, what's the point of taking a vector and making it longer or shorter? Well, if you had these two vectors, and I wanted to find the angle between those two vectors, does it make a difference if I use that to find the angle? Or I do something like this. Shorten the sides up. Does it make a difference which one I use to find the angle? No. It's going to be exactly the same angle, even though the sides are shorter. Yeah, but the angle's the same. So a lot of times if you want to find the angle between two vectors, you can work with shorter sides if you want to, if it makes your problem easier. Any question on that? All right, so last thing in this part. We talked specifically about how we can use vectors mainly in 2 applications. We mentioned velocity and we mentioned force. Okay? We're going to look at an example that uses velocity. Okay, when you write a vector in 2D, how many parts does it have? How many components?
There's 2.
2. What do we call the first component?
Horizontal.
The horizontal, and then the second component
Vertical.
is the vertical. So what I'm going to do is I'm going to give you a problem like this. I'm going to say that we're going to throw an object at a certain angle and a certain speed, and I want to convert that to a vector. Do vectors have angles in them?
No.
No. So if I give you something with an angle, you can't directly write that number down when you're writing a vector. Okay, we gotta use that angle to figure out what the vector would be. Okay, I'm going to show you how we do that. Okay, so this is going to be the diagram that gives us the formula for a velocity vector. Now I know normally when you throw something, it does start to curve because of gravity. We're going to keep it simple and just, it goes straight. So we're in outer space or something. It just keeps going straight. Now we said that vectors have two components. The way you can see the two components in this diagram is if you draw a line straight down, the arrow that I just drew in red, that is the horizontal component. If you stack this arrow in green on the end of it, you just built the black vector by stacking together the red and the green one. This is what we need to figure out. How long is the red one? How long is the green one? And that's going to be what we put in our answer for the vector. So I'm going to tell you two things. One thing I'm going to tell you is the speed that we're throwing an object at, and I'm also going to tell you the angle that we're throwing it at. The angle is right here. That's the angle with the ground. This line in black is my vector. I'm going to name these other two sides x and y. What position is the side that's labeled x relative to that angle?
It's adjacent.
That is adjacent. What position is the side labeled y relative to that angle?
Opposite.
That one's opposite. And the side that has the vector v,
Hypotenuse.
that's the hypotenuse. Okay, let's start with x. What trig function would involve x, which is adjacent, and the vector v, which is the hypotenuse?
Cosine.
Yes. So the cosine of our angle would equal adjacent over, now what's the formula for cosine? Adjacent over
Hypotenuse.
hypotenuse. And what do we want to put in the bottom here? What about our hypotenuse? We want to put the what of the hypotenuse?
It's the magnitude.
The magnitude, exactly. It's the magnitude. So it's the length of the adjacent over the length of the hypotenuse. And our hypotenuse was given as a vector, so we need to put those lines around it. Okay, so now, if you figure out what goes in that box, this is the horizontal component of our velocity vector.
8.66.
Well, we don't have any numbers
Oh,
yet, so we just need our formula that we would fill into. So what would you get if you move that to the other side and you get x by itself? Yep.
The magnitude of the vector multiplied against the cos of the cosine of theta.
Yep. So that's your formula for the horizontal component. Now we need the formula for the vertical component. Well, it's pretty much the same thing, except instead of adjacent, you use opposite. So what does that mean our trig function is going to change to?
Sine.
It's going to be sine instead of cosine. But other than that, it's the same thing. Okay, so that's how you calculate your horizontal component. Or in terms of a speed problem, this would be the horizontal speed of your object. This is how you calculate the vertical component. That's your vertical speed. Okay. And if you wonder what's the difference between horizontal and vertical speed, well, if I take like this pen and I throw it straight up and it just comes back down, it had no horizontal speed. I didn't throw it horizontally. I didn't throw it perpendicular to gravity. I threw it right into gravity. So the horizontal speed was 0, and the vertical speed was, well, whatever I threw it at. Versus if I take this pen and like throw it like a dart, it has no vertical speed. Right? All the energy is going horizontal. All right. Any question on the difference between the two? All right. So let's use those formulas to figure out what's going on. So we're throwing an object at 50 miles an hour at a 30-degree angle. So first of all, if you throw something at an angle towards someone, it is not going at the person at 50 miles an hour because you didn't throw it straight at them. You threw it at an angle. So it's going 50 on an angle. Some of the energy is pushing it forward, other energy is pushing it up. So it says find the velocity vector. Write the answer in unit vector form. Remember, unit vector form means I and j. All right, so let's get our formulas up. Okay, so let's start with the horizontal component. Can somebody tell me the equation I'm gonna, when it's all filled in, using my numbers, what it will look like?
Sine of 30 degrees.
So 30 is my angle, and what's the magnitude in this case?
50.
50. Remember, speed is the magnitude.
So 50 times cosine 30.
50 cosine 30. Okay, we'll figure that one out. What's going to be my formula for the vertical? Yep,
50 sine 30.
50 sine 30. Okay, now we need to figure that one out. Okay, if you type in 50 cosine 30, let's say to 2 decimal places, what do you get?
For cosine, you get 43.3.
You know what, that's good. 43.3.
All right.
We'll go with
You
that.
just want to round to the first one?
Yeah, 43.3. And what do you get for the vertical one?
25.
Exactly?
Yeah.
Okay. What letter do we need to put on the horizontal one if we're going to write it in unit vector form?
For the horizontal, you said?
Yeah.
That would be I.
So that's I, because right now that's just 2 numbers in boxes. That's not a vector. Those are the numbers we need to write, but we got to write them the right way. So 43.3i
Plus 25j.
plus 25j. That is the velocity vector if you throw something 50 miles an hour at a 30-degree angle. 43.3 is the horizontal speed, so that means like if you had a radar gun and the object was coming straight at you and you pointed the radar gun at it, it would say 43.3. If you were in a helicopter, like above the ball being thrown, and you pointed a radar gun down at it, it would be coming up at you at 25 miles an hour, at least initially when it leaves your hand. And then gravity would slow it down, right? But initially when it takes off, it would be going up at 25 miles an hour. Okay, that's how you write the velocity vector. Any questions on that?
No.
Okay, so that was the last 2 things in that part. Finding a velocity vector, and then finding a unit vector. Okay, so no other questions on that? Okay. Alright, so last thing we're going to look at today is what's called the dot product. So far, this is what we've done. We've done a vector plus a vector. And what did we learn happens when you add one vector to another vector, you get a new
Vector.
Yep. Okay. We've also done a vector minus a vector. What happens when you take a vector and you subtract another vector? You get another vector. Yep. What happens when you do a number times a vector,
Get a new vector.
you get a new vector. It's a scalar. It could be longer, shorter, or it could flip direction. What we haven't done yet is a vector times a vector, or specifically a vector dotted with a vector. Okay. So we're going to do vector dotted with a vector. That's what we want to figure out what's going to happen.
Oh boy.
Now the reason I don't say vector times vector is because when you do multiplication with vectors, there's actually two different ways you can do it. You can do what's called a dot product. You can also do what's called a cross product. They're very different. Cross product only exists in 3D. So that's why it's not something we're even going to look at yet, because we haven't gotten to 3D. And even when we get to 3D, we don't do cross products in this class. Okay, so when we multiply vectors, it will always be a dot product. But understand there is another way to do it that I'm not teaching you about. All right, so let's say we had two vectors like that. Two vectors in unit vector notation. The A1, the B1, the A2, and the B2, those would all be numbers. Kind of like, I'm just trying to find an example I might have. Yeah, kind of like this. When we do an actual problem, you'll have like a 2, a -3, a 5, and a 3. Okay, you'll have all numbers. And what we want to do is find the dot product. So the dot product is going to depend on 4 things. This number, that number, that number, and that number. Remember, those things are all numbers. So dot product, very easy calculation to do. To find the dot product, you take the 2 that are in yellow and you multiply them together. So you do A1 times A2. Then you do plus, and then you multiply together the 2 that are in green. B1 times B2. And that's it. That's how you find what's called the dot product. So multiply the 2 numbers in front of I together, 2 numbers in front of J together, and add them up. So let's see if we can figure out what that question mark is on the other side. A1 and A2 are numbers. What do you get if you do a number times a number?
A number.
You get a number. And then B1 times B2, that's a number times a number, which is going to be another what?
Number.
Another number. And what do you get if you add a number to a number?
A number.
You get a number. So that's what the dot product gives you. It gives you a number.
We don't keep the I's or J's.
Nope. Nope. So an example answer for a dot product, 13. Just the number 13. Now what you do with that number, that's what's important. Okay, I kind of already hinted at what you're going to do with it. It's used to find the angle between 2 vectors. And that's the last thing we'll do today if we get to that. Okay. So let's try to find this dot product. This is bold. That's bold. So I want to find V dot W. That's how you say that. V dot W. So the calculation is going to look something like this. You just have to fill in what goes in each parenthesis. Okay. What's going to be the first 2 numbers I multiply together?
2 and 9.
2 and 5.
2 and 5.
And the next 2 numbers?
3 and 3. -3 and 3.
-3 and 3. Okay. What's 2 times 5?
10.
10. And what's -3 times 3?
-9.
-9. And 10 plus -9?
1.
1. Yep. That's it. That's your answer. That is the dot product between V and W. Any question how we got 1? let's try it the other way. Instead of v dot w, let's try doing it w dot v. How would you write it specifically if I want it in that order? W dot v. What would you put?
5 times 2.
5 times 2.
3 times -3.
3 times -3. But what do you get for the dot product?
1.
Still
You
1.
still get 1. So what property do you think that means? We talked about this property yesterday.
Commutative.
Yes, the dot product is commutative. It doesn't prove the dot product is commutative, but it suggests, it implies, based on that example, that it is. All right. And let's try another dot product, v dot v. So you're basically pretending like you're dotting v with another vector that's exactly the same numbers. So what would be the calculation for v dot v? Yep.
2 times 5 plus 2 times 5. Oh, wait. Oh, wait, never mind. Hold on.
2 times 2.
2 times 2.
And -3 times -3.
And -3 times -3. You're just pretending like it's two vectors, but the numbers are exactly the same. Yep. And what would you get when you simplify that? 13. Yep, that's the dot product. So any question on, I'm not going to do D, but any question on finding those dot products? Okay. I have more. Okay, let's find this dot product. This time I didn't write the vectors with i's and j's. I used the older notation we learned, the first one. Okay. What's going to be the first two numbers that get multiplied together?
2 and 0.
2 and 0. Next two?
6 and 0.
6 and 0. And what does that give me a dot product of? 0. Now, is that 0 the number, or should it be a bold 0 like a vector?
0 is a number.
It's a number, right? Dot product gives you a number. So the answer to that problem is the number 0. Any question on that one? Okay, the dot product is distributive. Just like when you see something on the outside of parentheses with regular multiplication, and you can distribute it to what's inside, you can do that with dot product. So if you needed to do a calculation like that, you could add the vectors together first, and then find the dot product with u. Or find the dot product with v, then find the dot product with w, and add those two results together. That's distributed property. We're not going to prove that it works. I'm just going to tell you that it works. You don't believe me?
No, I believe you.
All right. So yeah, we're doing pretty good. So the last thing we're going to do is find the angle between two vectors. That's the application of dot products, finding an angle. Okay, so when I talk about finding an angle, I mean if you had a vector like this and a vector like that, I'm talking about that. It's the angle between the two vectors. So to find the dot product between two vectors, the formula that we use is based on the law of cosines. Now we studied law of cosines. We did that maybe 3 or 4 academic weeks ago. Because technically, you don't need this formula. if I gave you something like this, and let's say I drew a vector like that, another vector like that, and I asked you to find the angle between them, what shape could you turn this into that we could use with law of cosines?
Triangle.
We could turn it into a triangle. These would have little arrows on them. That doesn't really matter. So there's my arrows. Yeah, we could turn this into a triangle. And then what could you figure out about each side based on the fact that it's on a grid?
The length.
Yeah, you could find the length of each side. However you want to do it. You could use Pythagorean theorem. Like if you made a triangle out of each side, 1, 2, 3, 4, 5, this side's 6, this side's 4, and if you find the hypotenuse, that's that side, right? And you could do that with all of them if you wanted to. Do the green one, you could find that one, and the blue one, you could find that one. So you could do Pythagorean theorem 3 times. You could figure out the length of all these sides, and when you know all the sides in a triangle, we call it side, side, side. And law of cosines can be used to figure out any angle you want to know in a triangle, as long as you know all the sides. And we would be interested in the angle right there. So we could do it that way. But think how long that's going to take. You're going to do Pythagorean theorem 3 times. I mean, that's going to take at least a minute and a half to do all that out. Then you're going to do law of cosines. That might take a couple minutes. So it's going to take a while. Well, we can shorten that whole process using this formula. This does exactly the same thing, but in a quicker way. I could prove it, why it does it, but we're not going to go through the proof of the formula. But hopefully you understand that it has something to do with law of cosines, because it has cosine in it. So the cosine of the angle is the dot product over the product of the magnitudes. That's the formula. It's the dot product over the length of u times the length of v. So the nice thing about the formula is there's nothing in it that you haven't done. We've done magnitude. We've done dot product. That's all you have to do is find those 3 things. And then we do have to get rid of this cosine at the end. What do you do to cancel out regular cosine?
Inverse cosine.
We're going to do inverse cosine. Yeah, but that'll be the last step. Okay, so let's see if we can find the angle between these 2 vectors. And let's draw them. See if we can get an idea what the angle should be, and then we'll find it. So let's take 4i minus 3j. We start here. 4i means to go which way 4 units?
4. Going to the right.
4 to the right. 2, 3, 4, and then 3 units
Up. Down.
down.
Sorry.
Okay, so there's 4i minus 3j. Now let's start here again. 2i plus 5j. So 2 units to the
Right.
right, and then
5 units.
1, 2, 3, 4, 5. So that's the angle we're looking for right there. How much does it look like that angle might be?
Around 150.
Give her 135.
115, 120.
Yeah, I mean it's a little bit more than 90. Might be easier to see if you group it all together. Group it. And then you could kind of move it, and you could rotate one side flat. Kind of look at it that way. So, 135 would be halfway towards the next quadrant.
Take
So
that one back.
it's not that much.
110.
Yeah, it's maybe, I'd say 110, 100, because 90 would be right there. So it's basically just a question, how much more is that little sliver? Maybe it's like 10, 12, degrees. Let's see what it is. Okay, so the first thing we need is the dot product. what's going to be my calculation for the dot product?
4 times 2
4 times 2. Yep.
plus -3 times 5.
Negative 3 times 5. That's 8.
8.
And negative 15.
Oh, -7.
What is it? Negative what?
7.
Yep. That's your dot product. Okay, the next thing is the magnitude of u. What symbol do we always start out with when we're finding magnitude?
J.
Not a letter, I'm thinking of a symbol.
Oh. Theta. Square root.
Square root.
Oh.
Whole thing goes under its square root. Alright. What goes under the square root?
4 squared,
Which is how much?
16,
Okay, next one.
plus -3 squared, which would be 9.
Should be 9.
Should get you 25, square root of 25, which would equal 5.
Most of the time the magnitude does not come out to a nice number, but it did this time. Okay, magnitude of v. What's the first thing we put?
Square root,
And what's going to go under it?
or 2 squared,
2 squared, which is 4,
Plus
5 squared, which
plus 5 squared, which is 25. So the magnitude of v is how much?
square root of 29.
Yep, just leave it like that. Don't round it, because that's going to mess up our answer. Now, the 3 things that are circled, you're going to plug those into the formula. Cosine theta equals the dot product over the product of the magnitudes. Cosine theta equals dot product in the top, product of the magnitudes in the bottom. Okay, now solve that equation for theta, and that's going to be how big the angle is. What do we have to do on both sides to get theta alone?
inverse cosine.
Yep, take the inverse cosine. And up to this step, I can use an equal sign because this is exact. I have not rounded yet. Okay, so it's still exact. Now, in the next step, I'm going to round it off. And remember, we're thinking maybe around 90 to 95 to 100, somewhere around there. Okay, so inverse cosine of -7 divided by, you need to put the denominator in parentheses because it's more complicated than a single number. So 5 square root of 29. Close your denominator, close your inverse cosine. That's how you have to type it in. Okay, and does that line up with what we thought?
About,
Yeah. We said it was bigger, around 100 or something, we guessed.
How many decimal places do you want us to round to?
Let's
2 or
just go,
3?
we'll go 2.
Okay.
So it's 105.07 degrees. That's this angle. Right there. Now that angle, that's not anything special. That's just a random angle. There are 3 numbers that if it came out to these angles, it would be special. Does anyone have a guess what angle, if it came out to that, might be something special?
90.
90, yep. Comes out to 90 degrees. That means the vectors are perpendicular.
180.
180. So 180 would be kind of like 2 vectors that point in opposite directions. That's an angle of 180. And if you position them like this, it makes it easier to see what they are. What do you think those 2 vectors are?
0. Oh wait, I got a special thing for it.
Those are negative version of each other.
They are the negative of each other. And how might you describe these 2 things in geometry because of the way they look?
They're parallel.
They're parallel. So an angle of 180 is parallel. An angle of 90 is perpendicular. There's one other special angle.
270.
360.
45.
Well, 360 would be the same as
45.
something else.
0.
0. An angle of 0 between 2 vectors would look like this. And it's easier to see them if you put them like this. What would those 2 vectors be?
Parallel.
They're also parallel. So there's two cases for parallel, and then there's one case for perpendicular. And that's what we're going to finish up with. So if two vectors are perpendicular, the word they usually use to describe that is orthogonal. That's a word that I usually see associated with vectors. I don't usually see it in too many other places. Maybe when you talk about planes, but definitely when you talk about vectors being perpendicular, the word they use is orthogonal. So if you see that on the test or in the homework, determine if the following vectors are orthogonal. I'm asking you if they are perpendicular, which means they meet at what kind of angle?
90.
They meet at a 90. Yep. Now there is a quick way to figure out if two vectors are perpendicular. Really quick way. All you have to do is find the dot product. If the dot product comes out to 0, then the vectors are automatically perpendicular. Let me draw two vectors that are perpendicular, and let's see if that works. Get rid of this. Okay, I'm just going to draw two random vectors that are perpendicular. Does everyone agree those are perpendicular?
Yes.
Okay. So then their dot product should be 0. Well, let's check it. How would you write down this first vector in terms of like i's and j's? How many i's does it have?
6.
1, 2, 3, 4. Yeah. 6i. How many j's?
3.
How many?
0.
0. It doesn't go up and down at all. Okay, let's do this one. How many i's does this vertical one have? No i's. How many j's? 3j. Let's find the dot product. 0 times 6 is how much?
0.
It's going to be 0. What's 3 times 0?
0.
That's also 0. And 0 plus 0 gives you 0. So anytime two vectors are perpendicular, the dot product will always come out to 0. Right? Even if you turn them, rotate them together, they'd still come out to 0. I don't know if they're stuck together, but yeah. So if you could figure out what those two vectors are, if they lined up on nice points, I don't think it lines up nice, but the dot product between those would still be 0. All right, so let's check these two vectors. 2i plus j and I plus 2j. Let's find the dot product. Okay. Well, yeah, what are the first two numbers you would multiply? Yeah, there's a 1 here if you want to put it. 2 times 1. And the next two.
1 times 2.
1 times 2. That's 2 plus 2, which is how much? Okay. So are they perpendicular?
No.
No. The dot product has to be 0. So the answer to the problem is not 4. The answer to the problem is no. They're not perpendicular. Right? And if you draw them, it's going to be really clear that they're not perpendicular. Right 2, up 1. Right 2, up 1. Right 1, up 2. Right 1, up 2. No way. Those not even close to 90. What could you do if you could only make one change to make those perpendicular? You could change one thing.
Change the 1 to a 0. Or is that?
No, changing something to a 0 there, just doing that one change wouldn't give us something perpendicular. Put what?
We want them not to be a negative number.
Make any one of them a negative number. So go ahead, pick which one you want to make a negative.
The 2 and the b.
The 2 and the V. So let's watch what happens if you draw that.
Yeah, okay.
Start here, go left 2, up 1, and now go right 1, up 2. Do those look perpendicular?
Mm-hmm.
Yeah, they are. But you'd have to put a negative in to do it. And the negative wasn't there. All right. Any question on that one? Okay. So, last case. Parallel. If 2 vectors are parallel, I showed you somewhere, I showed you 2 different cases. The angle could either be
0.
0 or
180.
180. Yep. So really, you still do, there's no shortcut to this. To figure out if they're parallel, you still got to do the whole problem. The perpendicular is nice because there's a shortcut, okay, but not for parallel. All right, so determine if V and W are parallel. All right, so let's start with the dot product. What's 4 times 20?
80.
80.
No.
And what's -5 times -25?
125.
125. So that gives me a dot product of how much?
205.
205. So I don't know if they're parallel yet, but I know that they are definitely not what?
Perpendicular.
They are not perpendicular because the dot product would have to be 0. That's all I know right now. They're not perpendicular. Okay, magnitude of V. What's 4 squared?
16.
And 5 squared.
25.
Okay, so what's the length or what's the magnitude of V?
41.
41.
Square root of 41.
Square root of 41. Okay, and the magnitude of W. Square root of, what's 20 squared? Same as 2 times 2 with 2 zeros on it.
400.
400. What's 25 squared?
625.
625. So the length of that is what's 400 plus 625?
1025. Square root of 1025.
So let's fill it all in and see what we get. Keep in mind, what are we hoping for if we're going to get parallel? The angle is either
0 or
0, 180.
0 or 180. So that's all we got to check. Okay. Cosine theta equals, what goes in the top?
205.
205. And in the bottom?
Square root of 41 times the square root of 1025.
All right. So let's multiply together what's in the bottom. See what happens. The square root of 41 times the square root of 1025. What do I get?
205.
Where else is that answer?
On the numerator.
It's in the numerator. That gives you a hint. Something special is going to happen here. What do you think is going to happen?
It's going to be 0.
Is whenever the top and the bottom come out the same, you can technically stop there because we already know what's going to happen. But let's just finish it off. What's 205 divided by 205? 1. And what do you do on each side to get rid of cosine?
Negative cosine.
What's it called?
Inverse.
Inverse cosine. Type in the inverse cosine of 1. You get an angle of 0 degrees. So now, what does that mean? Are these vectors parallel? Yes. Yes. Determine if they're parallel. Yes, they are. So even though you still have to figure everything out, The hint, when you get to this point right here, if these are the same, or if they're opposites, like negative 205 and positive 205, they would be parallel. So if these are the same or opposites, then the vectors are parallel. So when they're the same and we divide them, we got a 1 here. What if they were opposites?
Negative one would be there.
Right. So basically another way to say it is if this number comes out to 1 or negative 1, they're guaranteed to be parallel. But you don't know if this number comes out to 1 or negative 1 until you figure basically everything out. And that's how you can figure out if vectors are perpendicular, orthogonal, or parallel. Any questions on that? Okay. All right, I need to adjust the homework a little bit. Actually, that's not going to be 352. All right, let me figure out. Okay, so the homework is both those pages. 352, 7 to 17, odd. So I think that's six questions. And then 344, 47, 48, 55, and 56. Okay, so for those of you that are going on the senior field trip tomorrow and have the environmental field trip the next day, I won't see you for the rest of the week. So the plan is to have the take-home test open on Thursday at 2:40, and it will be due Friday by noon. Is there anyone that's not coming in the rest of the week that is unsure they want to do that? They don't want to do it as a take-home. Okay, if it's not in by 12 on Friday, it's going to close and it's just going to give you a 0.
So I'll be here Friday.
If you are here in person, you can just take it in class, but you'll be able to use your notes because it's like a take-home. Okay, so if you're going to be here in class on Friday, you can use your notes, you can use your textbook, you can use anything.
They said it closed at noon.
Well, if you're going to be in class, I'm going to open it separate for those people, but for the take-home, that one would be at noon. Is there anyone that has a concern about doing it as a take-home?
I don't know, but you should